Good afternoon, everybody. I am Shravan, PhD scholar from NIT Goa. I am working under guidance of Dr. C. Vaijayanti. My presentation is on vector control of interlinking converter for DROOP controlled power flow in AC/DC hybrid microgrids. So, as we are aware, microgrid is a small power system, as shown in the figure, which has its own generating units, loads, energy storage systems, all connected together and operating on basis of some controls. So, this microgrid can be of two types, DC and AC, and combining these two we will get a hybrid microgrid. The main influencing factor for the formation of hybrid microgrid is we can put AC loads on AC side and DC loads on DC side, avoiding the conversion losses. So, this is the example hybrid microgrid, which has AC subgrid, DC subgrid, connected by means of an interlinking converter. Both the subgrids have their own generating units and loads. So, now we will see how the power sharing can be done between these two subgrids using DROOP control technique. DROOP control technique, as we are aware, that frequency and magnitude of the voltage in case of AC sources is dependent on active and reactive power loading on the source. Similar case in the DC for the DC sources. So, in case of AC sources, we equalize the frequencies of all the sources intentionally to make them share the power as a part of DROOP control technique. Similar way, if we see in similar way in the case of hybrid microgrid, if we see both AC and DC subgrids as two different entities of powers, we can also have power sharing between these two. But comparing frequency and voltage cannot be done directly because these are the quantities of different dimensions. So, we parentize them and bring them on a common platform, and the error or the difference between these two values, parentized values, can be given to a controller, and the amount of power flow can be found out, and this amount of power should be flown from one subgrid to another subgrid, and this is to be done through this converter, interlinking converter, which is the bridge for the two subgrids. So, we need to control that accordingly. This is my simulated hybrid microgrid. It has a AC subgrid, DC subgrid, both are connected through a converter, 3-leg converter, interlinking converter. So, we need to control the switches of this converter, this interlinking converter, in order to have our required power sharing. The control technique used here is vector control technique. So, if we see from DC side, this IC or interlinking converter is nothing but an inverter. We can generate pole voltages using inverting action, and the poles of this 3-leg converter are connected to an AC source, and this can be seen in simple form using this single line diagram. Two sources are connected through a line. This left hand side is Vs at angle theta 1 is AC source connected, and the right hand side are the pole voltages, which have fundamental component and harmonics. So, the direction of power flow can be controlled by making this theta 2 leading or lagging with respect to theta 1, and the amount of power flow can be controlled by the difference of the theta 1 and theta 2. Similar case we can take for the reactive power flow. We will consider there the voltage amplitudes. So, for the power flow control, we are controlling the pole voltages. To control that pole voltage, we need to generate appropriate reference signal. That reference signal we will generate using our vector control technique. This is a simple technique. We will apply KVL for the 3 phases. As these equations are in stationary reference frame, we will transform this into rotating reference frame. We will get VSD and VSQ in this form. And real and reactive power expressions in DQ0 frame will be like this. Vector control, feature of vector control is we have to transform the ABC reference frame parameters into DQ0 such that the AC side voltage vector completely aligns on the Q axis. That means D-axis voltage is 0 completely. By making this, we will get P and Q directly proportional to the respective axis currents. So we are getting decoupled control on the active and reactive powers. And putting this VSD equal to 0 in the above equations and rearranging these equations, we can find out the pole voltages in DQ0 frame. Pole voltages are nothing but product of inverter gain and the reference voltage magnitudes. So we can find out the reference voltage using this. And slightly rearranging the equation, VID can be made a combination of two different terms. Why I have separated these is this omega s ls isq is the output of q axis current controller, and another term is the output of the d axis controller. So the combination of these two will get this expression, and dividing this with inverter gain, we will get the reference voltage magnitude for the d axis. In the same manner, we can find out VIQ star. These two will again inverse transform into ABC reference frame to get 3 reference voltages for the 3 legs of the converter. This is the control block of the interlink converter. These FPU and VPU will get through the DROOP equations. The error we will give to the controller, whose output will give us the current value of the Q axis. The error of the current we will give to the another controller, whose output, and in addition with the feed forward terms, we will get reference voltages in DQ0 frame. These we will go, then we will go for the inverse Sparks transformation. We will get 3 modulating signals for the 3 legs of the converter, and we can perform the sine triangle PWM to get 6 pulses. These are the system specifications which are used. The minimum and maximum quantities are according to the bandwidth in which we are allowing the parameters to DROOP in relation with their active power loading. And both the subgrids are equally rated for 10 kilowatts of full load. We have gone for 2 simple cases: a loaded DC side with 5 kilowatts and a put AC side for no load. In the first case, considered individually, when AC side is at no load, frequency of the AC bus should be at 51 Hz, and voltage of, and when we are putting 5 kilowatt load on DC side, its voltage should be at the average of minimum and maximum voltages, that is 605 volts. But as we are controlling these two to share the power, and they are equally rated, they will share the 5 kilowatt load equally, 2.5 kilowatts each, and the frequency of AC bus is settling at 50.5 Hz and voltage is 610 volts. These voltages, when per unitized, will be equal in value. So they settle at the equal per unit values. Similarly, in second case, when we are putting 10 kilowatt load on DC side, power is getting shared equally. So frequency of AC bus is settling at 50 Hz and voltage is settling at 605 volts. These per unit values are equal. So finally, conclusion. We are able to control the converter using vector control technique, and according to the power ratings of the subgrids, we are achieving the DROOP control power sharing according to the DROOP control which we have used. Thank you.
Here is your opportunity for microgrids, hybrid AC/DC. Where are your questions? Now it may be Friday afternoon, but yes, very good. If we could have a microphone over the far left here.
Hi, I'm Mithun Chakravarti from Tata Power Delhi Distribution. On the cost of microgrids, today what we see, there are a lot of microgrids being used in off-grid solutions for providing electricity access in rural areas which do not have connectivity. But the cost at which the power is being provided in those areas is very high. In some of the aspects that we have seen, it may go up to 24 to 30 rupees per unit that a rural is getting power, and that also for 4 hours a day. What are the various areas in which microgrid improvement is taking place to make this affordable and at par with what we are seeing in urban areas?
Can you repeat the question once again?
The cost of microgrids for supply to rural areas that we see today, the per unit cost comes to around 24 to 30 rupees in some cases.
Okay.
And the rural areas also get electricity only for 4 hours a day.
Okay.
So what are the areas of improvement in the various components of a microgrid that are being done to make this more affordable for rural areas and also increasing the power from 4 hours to 24 hours per day at affordable rates?
Actually, these economic terms I am not related to, but
this could be to the panel as well. That's an open question to the panel.
Okay, if you could maybe add a bit more on the general scene of the motivation for this solution. Is it predominantly technical, or is it economic, that it's more economical to get to areas with standalone microgrids than it is to build connections to the nearest grid supply? What do you see as the main drivers for microgrids?
Main drivers for the microgrid is as generation is happening on the load side itself, we can have lesser losses. So the power means load on the generating stations, it is reducing considerably. So these led to the factor formation of microgrids. And since nowadays DC loads are increasing in number, formation of, so we are going for DC sources, renewables, solar panels, all these things. And still our power system is on the basis of AC power transfer. And in India, many of the power loads still are working on AC power. We are going for AC microgrid also. To get the advantage of both of them, we are going for a combination.
So are you looking at microgrid where there is already the option of a grid supply, or are you looking at areas which don't have supply at all? Are you looking at delivering something in an extreme rural area where there is no supply, and I don't know if that's for 0.01% or whether it's on 1% of India or whatever it is, or if it doesn't exist at all? Well, most countries do have at least a few places without the supply. Or are you saying, like the US, that moving to microgrids in a big way, even when all the systems exist already? Oh, okay, I think maybe yes, you might have a comment here from the audience, please.
Hi, thank you for this opportunity. My name is Abubakar from Central University of Kerala. Actually, sir, I wanted to chip into the question you're asking because I'm working on something related to that. You see, the Indian government has ambition of achieving a gigantic size of renewable energy by 2022. And then, according to electricity supply in India, there are a lot of rural locations that doesn't have electricity. I'm from Kerala, where we have a lot of hilly stations. So if we said we are going to move the national, we are going to extend the national grid to such hilly location, so that means higher percentage of coal is also required to be burned to generate that electricity. So the best way and the economic way of achieving reduction in carbon emission electricity generation is to create a microgrid, whether being in terms of village or in terms of household level. So I think by doing that, it's more economical to the government in achieving the mission of 2022 and also reducing the carbon emission electricity and heat generation. That's what I want to say.
Does that mean that if you provided a grid solution that you couldn't still use those same sources? Presumably, if you provided a grid, you can still build all of those renewable sources in the locality?
No, sir. Considering the amount of fossil fuel we are burning in generating electricity in India, so it means extending the grid to such location that doesn't have electricity means burning more coal and generating more fossil global greenhouse gases.
It wouldn't have to be, surely. That's.
No, I'm talking in response to India.
Okay.
I'm not talking in terms of globe. Because in India, for now, there is no much penetration of renewable. Major penetration is large-scale wind electricity. So, okay, let's take example of large-scale wind electricity. If you have a wind farm, it's located far away from such location. So it means extending the grid from there, there's a lot of electricity losses, transmission losses that are there. So you see, the achievement or the goal of establishing the wind farm is not even achieved. So what will be the solution is to establish a microgrid at village-wise or at a household level. I'm talking in regards to India, not in regards to the globe.
Yeah, I understand that in full, and thank you very much for your contribution. Yes, so if there is a substantial component without, then clearly that is a way of going. So now I think we move to the panel discussion, and first of all we have a comment here.
Yeah, I think you are right, but we need to improve the grid code requirements for the establishment of these smart grids or microgrids, because we need here frequency and voltage control, for example, of the side of a PV system in order to ensure good island operation of these grids, but also to permit the reconnection with the interconnected system. For that reason, I think your opinion is very important to integrate renewable energy here in India, and also it's important to learn about the mistakes that we have done in other countries, for example, in Germany. And the major challenge here is to find the right grid code requirements for our distributed generators in order to improve the operation of our grids here in India.
Okay, a very interesting input there in terms of, and there are two extremes in terms of looking at that you need a well-specified development of microgrid, or a free-for-all. And I was just about amazed going about this time last year to US and hearing the mass of drive towards microgrids with a rule system close to the traffic rules in India. There are no rules and you can do whatever you want. I know the Indian road system is still effective, and I'm amazed that there are so few accidents, and I would very dearly wish that the same thing will be the case in terms of microgrids trust in USA and maybe here as well. But being a European, we are, and working closely with many Germans, I have my little bit of doubt and my desire to have some rules in the game. So it's an interesting point of view here that we may need some rules even on the microgrid world. Any further comments or questions on the microgrid world, please, which is a big topic, and certainly over time it's going to be of great importance. Okay, if I can then ask if the panel, any of the panel members want to make any further contributions in context of hybrid, which I had a 1-minute notification for chairing this session, so I can't say that I'm an expert. It's probably, if I looked at all of the sessions, this was the one I was least informed about beforehand. But I did consider at the time what does hybrid actually refer to, and I can't say that it's a single thing. There are many different versions of hybrid, and we have had that in this session. Hybrids of many kinds. So, any further comments from the panel members? Okay, and from the floor? In which, yes? No? In which case, I would like to thank you all for your attention and your patience on a Friday afternoon. I do know that there is a session arranged for 4 o'clock for closing remarks. I don't know where that is meant to be, but I'm sure we'll be informed. So please enjoy your well-deserved coffee or tea and maybe something more. Thank you.